Hello and welcome everyone. My name is Vedant Thakre and my topic of the explanation is diffraction of light. So here is my basic information. You can just go through this information. So let's have a look at this. Firstly, we will talk what is diffraction exactly means. So whenever the light falls on the slit or an obstacle, it encounters the edges of that obstacle and it diffracts or spreads on the screen. This phenomenon is nothing but the diffraction of light. There are some causes due to this diffraction phenomenon. You can see on the screen. First one is the wave nature of light. Here, whenever the light falls on the obstacle and some light is absorbed by the or large light is absorbed by the obstacle. This shows that the light shows the particle nature, and whenever the light diffracts or spreads on the screen and very minimal amount of light is absorbed by the obstacle, then it shows that the light follows the wave nature of light. Okay, then second one is the cause of size. Here, in the diffraction phenomenon, the size of the obstacle or edges or the slit width is comparable with the wavelength of that light used. Okay, and third one is the interference of wavelength. Here, the Huygens principle proves that the diffraction phenomenon gives the wave nature of light such that the points of source of light has uh, act, act, acts as a secondary source of wavelength on the screen and interfere or overlap with one another to form an interference pattern on the screen. So one example is given on the screen, single slit diffraction pattern. Here, in this phenomenon, the light used is coherent and monochromatic light is used. It falls on this narrow slit firstly and diffracts into the wavelets, and these wavelet form are overlap or interference with one another to form a interference pattern on the screen. The interference patterns are observed in a workflow. You can see on the screen when the order of the diffraction is interference to form the fringe. The zeroth fringe is always a bright fringe, means the constructive interference is observed on the zeroth fringe or zeroth order of that diffraction. And first order upper maximum partial is observed, and first order bottommost fringe is also partially observed the brightness. Okay, and second order fringe is diffraction of light with the interference of dark fringe, and darkness is observed at the order second. Okay, then there are some application of this diffraction phenomenon. You can see on the screen. First one is the X-ray crystallography. Here the crystal is used, and the X-ray source is used to uh, study the atoms and molecule structure of that crystal. Here, the X-ray sources firstly fall on the crystal, and crystal diffracts that light on the screen, and you can see the particles are observed in such a way that some particles are interference with one another to form a constructive side by side nucleated particles, which is the constructive interference, and brightness is observed on that area. And whenever the light is diffracted in a scattered way, the darkness is observed on that screen. This shows the atoms and molecular structure of that crystal. Okay, and in the case of second one is the in case of spectrometer experiment. Here, the prism or the line density used by the grating diffraction grating is used to diffract the light. Here in the spectrometer uh, experiment, the light is fall on the prism or that diffraction grating to convert into different wavelength of light. Colorful lights are observed, and third one is the CD or DVD reading. Here, in case of CD or DVD, the light is detected to enclose or to open the data enclosed in a DVD or a CD. So, whenever the light is scanned on that RGB or colorful CD or the DVD, it interference the sources of that wavelet and forms the data and converts that data into the video and audio signal. Okay, and the respective data is observed on the screen. Okay, It is also used in the TV theater, movie theater, etc. And last one is the telescope resolution. Here, in case of telescope, the light is used to diffract and used to study the distance between the two stars or the two objects into the sky. Uh, and diffraction is very helpful in case of telescope resolution. Resolution is determine the how clarity is given by the telescope to observe that distance. Okay. Then in this PPT, we have discussed and conclude the topics that are wave nature of that light and mathematically derive the equation of diffraction grating. Diffraction grating, that is a d sin theta equals to n lambda. And also we have used the diffraction application in a real life technology to use the nature and to study the nature in a clarity way. Okay, there are some references you can see on the screen. I have taken the NCRT help to carry out this PPT, and the nature of that light is observed very clearly by these references. So thank you so much for watching my video.